Hello everyone. Today we are going to discuss about the standing waves in a air column. Means before video we have discussed that what is standing waves and what are the equations and what are the laws of vibrating string. When the standing waves are formed, means when the string is vibrated, then what is the standing waves are formed in a string. Then loss of string also we have discussed in previous video. Now we are going to discuss about stationary waves in air columns. Means here the air enclosed in a pipe is called air column. That means whenever if we take the some of the test tube, by blowing the air in the test tube we can hear the note. We can hear the some of the note. Or for example, in our childhood also we did that when we take the pen cap. If we take the pen cap, if we blow the air in the pen cap, then we can hear the sound note pitch, some of frequency. So those are called air columns. The standing waves formed in a air columns. Here, when air column is formed in a closed end, means closed pipe. What is meant by the closed pipe? The one side of the pipe is open and another side of the other side of pipe is closed is called a closed pipe. In other hand, the pipe is open at both ends is called open pipe. The air columns can be formed in open pipe and closed pipe also in many ways, in many different type of frequencies. If the notes are formed in a air columns are formed in a pipe in many ways with making notes of pitch is a complex note. Is a complex note. If we take the closed pipe, then here wherever the air enters, then at the closed side only the air particles does not move freely. They don't move freely. So that's why here note will be formed. And in other hand, if we take the open end, means at the open end, if the open end, the antinote will be formed because of air particles can move, maximum freedom is there. They can move in any part. So that's why here antinote will be formed. Here that when the air columns are formed in the standing waves are formed in a tube or air columns, then the mode of vibration with the lowest frequency. When the air columns formed in a tube, the mode of vibration with the lowest frequency. The mode of vibration with the lowest frequency is called as the fundamental mode. It's called a fundamental mode. And the lowest frequency which can be formed in a air column is the fundamental frequency. The mode of vibration with the lowest frequency is called a fundamental mode. And the frequency is called a fundamental frequency. The next one, when the frequency, the mode of vibration produces notes more than the other than the fundamental modes. More than the fundamental modes, if the modes of vibration produces notes of higher frequency, then that note is called overtones. The modes of vibration produces a note with high frequency. Notes of higher frequency are called overtones. Means whenever blow the air, then air column will be more. If the air column will be more, then the frequency of sound will be different. Means not the fundamental frequency. The frequency doesn't mean that whenever the air column forms, that only the sound we can hear, the pitch we can hear. Now otherwise we can't hear the sound. So here whenever the mode of vibration produces notes of higher frequency, then that is called as overtones. If the frequency of overtones are the integral multiple of fundamental frequency, means if the sound fundamental, more than the fundamental frequency, the overtones are going increasing. The integral multiple of fundamental frequencies are called harmonics. So that's why we are saying that here the fundamental frequency are first harmonic. If in case of second mode of vibration, earlier we have discussed in previous video in modes of vibration, the second one is the second harmonic or first overtone. Whenever the air columns are formed, standing waves are formed in a air column, in some string or in whatever the medium is there, then when nth harmonics and n minus 1 overtones will be formed. Already we have in previous video discussed about it. So here the mode of vibration with lowest frequency are called the fundamental mode. The frequency is called as fundamental frequency. When the mode of vibration produces notes with higher frequency are called overtones. For the frequency of overtones or integral multiple of fundamental frequency is called harmonics. So in the harmonics, now we have already discussed about that. The air columns formed in pipe means then closed pipe and open pipe also. Now the modes of vibration of air columns in an open pipe. What is meant by the open? Means pipe is open at both ends. Open at both ends is called open pipe. In that open pipe, when the fundamental frequency means the fundamental mode of vibration will be happened, then the two antinodes, between the two antinodes, one node will be formed. When in the fundamental mode of vibration in an open pipe, then already we have discussed whenever the open side antinodes are formed, so that's why both ends are open. So that's why two antinodes and one node are formed. And as well as when the length of the air column will be denoted as with L, then lambda 1 be the wavelength, fundamental wavelength. Then the wavelength of this air column is, we have that this one is the distance between the two consecutive or two adjoining node to the distance between the node to adjoining antinode, or the distance between the antinode to adjoining node, means this is the adjoining node to the antinode, is called lambda 4. The length will be the lambda by 4. And also here the distance between the node to the adjoining antinode is also lambda by 4. So here it is that lambda by 4 plus lambda by 4. Lambda by 4 plus lambda by 4 is the 2 lambda by 4. That means L is equal to lambda by 2. That means here we can write that lambda by 4, lambda by 4. So from that L is equal to lambda by 4 plus lambda by 4. That is 2 lambda by 4. 2 1s are, 2 2s are, total we can get L is equal to lambda by 2. From that, if lambda 1 is the wavelength, then whenever the air column happened in this fundamental mode of vibration, the fundamental mode of vibration is called lambda 1 is the wavelength, the fundamental wavelength for this air column. The wavelength is the lambda 1. So wherever L is the length of air column, then L is equal to lambda 1 by 2. Lambda is the wavelength, lambda by 2 is the length of air column. So lambda 1 is equal to 2L. Lambda 1 is equal to 2L. Then if nu1 be the fundamental frequency, we know that nu is denoted frequency is denoted with the nu, like that. Here when the fundamental frequency nu1 be the fundamental frequency, then V is equal to, we know the formula, when the speed of a wave in air is V is equal to mu lambda. There is no another medium, means like string. Only the air columns are formed in a tube. So that's why, so the frequency will be, we are measuring. So V is equal to nu1 lambda 1. Nu1 be the fundamental frequency, lambda 1 be the wavelength. Then nu1 is equal to V by lambda 1. The lambda 1 will be the, if we take in this outside, it will become denominator. Then nu1 is equal to, lambda 1 is equal to, from the equation 1, lambda 1 is equal to 6, lambda 1 is equal to 2L. We are substituting that one, V by 2L. Here nu1 is the fundamental frequency. In an open pipe, this is a V by 2L is the equation for the fundamental frequency. We should remember that one. Then nu1 is called as fundamental frequency, or first harmonic, fundamental frequency, or first harmonic. This is the fundamental mode of vibration in an open pipe. The next, the second mode of vibration. In the second mode of vibration, always we know that at open end antinode is formed. At open end antinode is formed. At closed end node is formed. Just don't be confused. At the open end antinode is formed. At closed end node is formed. So here at both ends the antinodes are formed. Between the antinodes, two nodes are formed. Total 3 antinodes and 2 nodes. 3 antinodes and 2 nodes. So here 3 antinodes and 2 nodes are formed. The length of the air column will be, in an open pipe, L is equal to lambda by 4, because of the adjoining lines. Here the antinode to the adjoining node is lambda by 4, and the distance between the two consecutive nodes or antinodes are called distance is lambda by 2. So lambda by 2 means node to the node distance will be lambda by 2 plus lambda by 4. So here lambda by 4 plus lambda by 2 plus lambda by 4 is 4 lambda 2 by 4. Then 2 lambda by 2 is equal, lambda 2 is equal to 2L by 2 we can get. So here is the nu2 be the second mode of frequency, means frequency of vibration nu2. That is called as a second harmonic, or first overtone also we can say that. So nu2 is the frequency of air column in an open pipe. That's in the second mode of vibration. In the second mode of vibration. So nu2 is equal to V by lambda 2 is the formula, as we know that, from the speed of a wave in A. Then nu2 is equal to lambda 2 is equal to, already we know that, 2 lambda 2L by 2 is the length of air column, means wavelength of air column. Then nu2 is equal to V by 2L by 2. From this 2V by 2L, because of denominator, the 2 is the denominator per denominator, so that's why it becomes numerator. Then 2V by 2L. Here 2V by, we know that V by 2L is the fundamental frequency nu1. V by 2L is the fundamental frequency nu1. So that's why we are writing that nu2 is equal to nu1, since nu1 is equal to V by 2L from the fundamental frequency. As that we can say that nu2 is a first overtone. Nu2 is a first overtone and or second harmonic. Second harmonic. Further, in the next mode of vibration, the air columns formed in an open pipe. When this one is the first fundamental frequency, as we know that, and this one is the second harmonic or first overtone, was in before earlier we have seen, and when in the next mode of vibration will be another harmonic for fundamental frequency also formed, and this will be the next mode of vibration. Next, in the next mode of vibration, the antinodes are 1, 2, 3, 4, means 4 4 antinodes, and 1, 2, 3 node means 3 nodes are formed. 3 nodes are formed. In that 3 nodes are formed whenever the next mode of vibration is called as, this is called as the third harmonic or a second overtone. Third harmonic or second overtone. So here the wavelength will be, the length of A column L is equal to, here the adjoining node to the antinode is lambda by 4, lambda by 2, lambda by 2 plus lambda by 4. Totally we can get when 6 lambda by 4. 6 lambda by 4. By doing LCM we can get 6 lambda by 4. 1, 2, 2 lambda, 2 lambda, 4 lambda, 5, 6 lambda by 4 we can get. So L is equal to 6 lambda by 4. From that L is the length of A column. Length of A column. Then L is equal to 6 lambda by 4. That is equal to lambda with the lambda 3, because of lambda 3 is the wavelength of a third harmonic. So that's why we are writing that lambda 3. So lambda 3 is equal to 4L by 6. That is 2L by 3. 2 2s are 2 3s are. From that 2L by 3. Here lambda 3 is the wavelength. And nu3 with the frequency of vibration. Frequency of vibration. Frequency of vibration. Then from the frequency of vibration we can write that V is equal to nu3 lambda 3. That is equal to nu3 is equal to V by lambda 3. V by lambda 3. That is equal to nu3 is equal to V by lambda 3 means 2L by 3. That is equal to 3V by 2L. Means nu3 is equal to 3 nu1 from the fundamental frequency. From the fundamental frequency we can write that nu3 is equal to 3 nu. For n number of modes will be formed in a open pipe. If n number of modes are formed in a open pipe, then we can get in general equation for the A columns the frequency in an open pipe. General formula for frequency in an open pipe is mu n is equal to NV by 2L. Nu n is equal to MV by 2L. We can write that nu n is equal to NV by 2L, or nu n is equal to N nu1. These two are the general fundamental equations for n number of modes. Means first number of mode, fundamental mode happened when n is equal to 1, 2, 3 up to so on. So we can write that where n is equal to 1, 2, 3 up to so on. We can write that. This is about when the A columns formed in an open pipe. For Telangana and Andhra Intermediate Board of Education, the open pipe question, and at the same time in previous class we have discussed about the standing waves. Means in previous videos part 8 and 9. The standing waves, that is the first long answer question, and this will be the open pipe. He asked for the long answer question for 8 marks in Telangana and Andhra Board of Intermediate Education. According to the Board of Intermediate Education, this is the 8 marks long answer question. Okay, the most important question in 8-9 videos, and this one also. Thank you. So, modes of vibration of A columns in an open pipe. The frequencies are found fundamental frequency and first harmonic, or second harmonic, first overtone, or third harmonic. So the modes of vibration will happen. Then the ratios of frequencies of normal modes of vibrations are u1 is to u2 is to u3 is equal to 1 is to 2 is to 3 we can get in the open pipe. So in general the equations of frequency for nth mode of vibration is nu n is equal to nv by 2l. Here nv by 2l means where n is equal to n is equal to 1 2 3 4 up to so on we can write that. So from that equation nu n is equal to nv by 2l and nv1 if in case of first mode of vibration if n is equal to 1 then v1 is equal to v by 2l the fundamental frequency. In that second mode of vibration then say 2n is equal to 2 then if we substitute 2v by 2l with the second mode of vibration that is the second harmonic or first order like that we can get the n is equal to 1 to n number of harmonics will be possible that is the harmonic. The notes are formed and the next one is the overtones are formed in that n minus 1 of harmonic. Here is this is the modes of vibration of air columns in an open pipe. Thank you.